Welcome to High Performance Pilot, where together we'll discover the secrets to improving our operational performance and so become more effective pilots. To achieve this, we're going to examine the required skills, knowledge and attitudes, collectively known as the core competency matrix. I'm David Summers, and in this episode we explore Identifies and Verifies why things have gone wrong, does not jump to conclusions or make uninformed assumptions. A behaviour within the competency of problem solving and decision making. We'll examine what it is, why we need to be proficient in it, and finally, how we are going to achieve it. The core competencies should not be seen as 9 individual elements. Effective operation requires them to be used together, effectiveness in one being dependent on effectiveness in the others. They are all interconnected. Problem-solving and decision-making skills are crucial when even the smallest error can have significant consequences. It requires a disciplined and analytical approach to problem-solving to make well-informed decisions based on accurate information. Successful problem-solving and decision-making can be seen as the end goal of the core competency matrix and requires proficiency in all the other competencies. What is the behaviour of Identifies and Verifies why things have gone wrong, does not jump to conclusions or make uninformed assumptions? Well, it refers to the process of thoroughly investigating and understanding the root causes of a problem or an error. Rather than hastily jumping to conclusions or making uninformed assumptions, pilots exhibiting this behaviour take a meticulous and evidence-based approach to problem solving. They recognise that understanding the true underlying factors behind an issue is crucial for implementing effective solutions and preventing future reoccurrences. Why is this behaviour important to us? The consequences of errors or malfunctions can be severe, posing risks to human lives and property. Therefore, it is vital we have the ability to accurately identify and verify the reasons behind any failure or incident. Here's why this behaviour is important to us. Accurate problem diagnosis. By avoiding premature conclusions or uninformed assumptions, we can focus on gathering relevant data and evidence to diagnose the problem accurately. This leads to a more precise understanding of the root causes and enables targeted solutions. Preventing recurrence. Jumping to conclusions without verifying the underlying causes can lead to the implementation of ineffective or superficial fixes. On the other hand, thorough verification helps ensure that the identified solutions address the actual problem, reducing the likelihood of recurrence. Safety enhancement. Identifying and verifying why things have gone wrong allows for a comprehensive analysis of safety-critical incidents. This leads to the identification of systemic issues, procedural weaknesses or training gaps, which can then be addressed to enhance overall safety in the industry. How can this behaviour be practiced? Developing the behaviour of identifying and verifying why things have gone wrong requires a systematic and disciplined approach. Here are some of the strategies that can be employed to practice this behaviour. Gather and analyse data. Start by collecting all available data related to the problem or incident. This includes factual information, eyewitness accounts, and relevant documentation. Carefully analyse this data to identify patterns, correlations, or discrepancies that can help determine the underlying causes. Apply critical thinking. Engage in critical thinking throughout the problem-solving process. This includes challenging assumptions, seeking alternative explanations, and considering multiple perspectives. By adopting a skeptical mindset and questioning initial conclusions, we can ensure a more robust analysis. Utilize tools and techniques. Employ various problem-solving tools and techniques, such as root cause analysis, fault tree analysis, which is drawing a tree diagram to understand all the possible causes of a fault, or use the 5 whys technique, which is basically asking why 5 times to get to the underlying cause of any problem or incident. These structured approaches help guide the investigative process and assist in identifying the underlying causes. To put this behaviour into context, let's examine the scenario of a crew experiencing unexpected engine parameter deviation. The aircraft is in the cruise at flight level 390, en route from the UK to the Canary Islands. The crew notice an increase in the oil temperature of one of the engines, accompanied by a slight decrease in oil pressure. In this situation, the behaviour of identifying and verifying why things have gone wrong, not jumping to conclusions or making uninformed assumptions, becomes crucial for the flight crew's problem-solving and decision-making process. Let's now see how they utilise this behaviour to deal with this non-normal situation. Observation and initial assessment. The flight crew first notice the abnormal engine parameters on their instrument display and receive an automated engine caution. They acknowledge it and verify the indications. Situation analysis. Instead of immediately jumping to conclusions or making assumptions about the cause of the abnormal readings, they start analysing the situation systematically. They review the engine system's normal operating parameters to ensure they have a clear understanding of the expected values. Gathering information. The crew consults the aircraft quick reference handbook and manufacturer's documentation to gain further insight into the possible causes of the observed deviations. They take into consideration factors such as ambient temperature, altitude, and current phase of flight. Cross-checking. To ensure accuracy and prevent hasty decision-making, the crew cross-checks the engine parameters with other indications and systems. They compare the readings with other engine instruments and relevant systems such as fuel flow and EGT or ITT. Communicating and collaborating. Recognizing the importance of teamwork, the crew communicates their observations and findings to each other, sharing their insights to foster a collaborative decision-making process. Troubleshooting and verification. Based on the gathered information and collaboration, the flight crew formulates a list of potential causes for the abnormal engine parameters. They prioritise the list based on likelihood and potential impact. The crew then proceeds with troubleshooting steps, such as verifying system controls, conducting engine parameter tests, and assessing any related warnings or indications. Consultation and decision-making. As the crew cannot identify the root cause or resolve the issue through troubleshooting, they initiate a consultation process with the company's maintenance control centre. They relay the observed abnormal parameters, their troubleshooting actions, and request further guidance or support. Timely response and mitigation. While awaiting further guidance, the crew takes appropriate mitigating actions, such as reducing engine power. They continuously monitor the engine parameters and the aircraft's overall performance to ensure the safety of the flight. By following this behaviour of identifying and verifying why things have gone wrong, not jumping to conclusions or making uninformed assumptions, the flight crew demonstrates a systematic and methodical approach to problem solving and decision making. This behaviour helps them avoid premature judgments, consider all available information, collaborate effectively, and make well-informed decisions in a time-critical and dynamic in-flight situation. We'll return to this example in future episodes to see how we apply other behaviours to it. Our industry has moved to a threat and error management model where we seek to operate with knowledge of the threats involved in our operation and therefore allow us to avoid or mitigate them. So before moving on to summarising the behaviour of identifies and verifies why things have gone wrong, we'll take a look at some of the threats produced if we are not proficient at it. Inaccurate root cause analysis. Failing to identify and verify the reasons behind incidents or problems can lead to inaccurate root cause analysis. This can hinder the implementation of effective solutions and preventative measures as the underlying causes are not properly addressed. Persistent issues and reoccurrence. Not engaging in a thorough analysis and making uninformed assumptions can contribute to persistent issues and reoccurring problems. If the true cause of a problem is not identified and addressed, it is likely to resurface, potentially leading to repeated incidents or accidents. Poor decision making. Making uninformed assumptions or jumping to conclusions can lead to suboptimal decision making. Decisions based on inaccurate or incomplete information can result in ineffective or inappropriate actions, potentially exacerbating the problem or causing unintended consequences. Missed learning opportunities. By not identifying and verifying the true reasons behind incidents or problems, individuals and organisations miss out on valuable learning opportunities. Without accurate problem analysis and informed decision-making, the chance to enhance safety, efficiency and performance through organisational learning is diminished. In conclusion, the behaviour of identifying and verifying why things have gone wrong is an integral part of problem solving and decision making. By resisting the temptation to jump to conclusions or make uninformed assumptions, we can ensure accurate problem diagnosis and effective solutions. Through systematic investigations, critical thinking, and the application of problem-solving tools, we can mitigate risks, enhance safety, and continuously improve the industry as a whole. Embracing this behaviour demonstrates our commitment to excellence and the relentless pursuit of safety within our role. Here are the key takeaways. The behaviour of identifying and verifying why things have gone wrong involves avoiding hasty conclusions and uninformed assumptions in problem solving. It is crucial for accurate problem diagnosis, preventing recurrence, and enhancing safety. To practice this behaviour, we should gather and analyse data, conduct thorough investigations, apply critical thinking, and utilise problem-solving tools and techniques. Before I finish up, I've received some great feedback for High Performance Pilot, and in the light of that, I'd like to introduce a new section to the show, the Golden Takeaway. Something to leave you with that encapsulates each episode's behaviour. So I'd like to take you back to 1989, a time when I was just starting my career. CRM had only just been accepted as a universal concept, so was still in its development stage. It's a long time ago, but this accident really does sum up the importance of the behaviour, identifies and verifies what has gone wrong. There is a lengthy UK air accident investigation report about this, which I suggest you track down, However, I will briefly summarise what happened and see how today's behaviour applies. British Midland Golf Oscar Bravo Mike Echo was en route from London Heathrow to Belfast Aldergrove Airport. Whilst climbing through flight level 280, they experienced severe vibration and the smell of fire in the cockpit. The crew quickly disconnected the auto throttle and reduced thrust on engine number 2. This seemed to remove the vibration and reduce the smoke in the cockpit. The crew diverted to East Midlands Airport and engine number 2 was subsequently shut down. On final approach at 2.4 nautical miles, engine number 1 suffered a sudden loss of thrust. Golf Oscar Bravo Mike Echo crashed 900 metres short of the runway threshold on a motorway embankment. There are 2 questions we need to ask. Firstly, did the crew identify what had gone wrong? The answer is no. A fan blade had broken on engine number 1, causing the severe vibration and subsequent smoke and smell. They mistakenly decided the problem was engine number 2, despite there being no indications that this was the case. However, there had been and continued to be engine parameter fluctuations on the number 1 engine, including high values on the vibration meter. Question number 2. Did the crew verify what had happened? Again, the answer has to be no. Reducing thrust on number 2 engine also resulted in a slight reduction in thrust on engine number 1. It was enough to considerably reduce the vibration caused by the fan blade problem on engine number 1, and so reinforce their incorrect diagnosis. They could have verified the results by independently applying thrust to each engine. I hope this example highlights the absolute importance of proficiency in the behaviour, identifies and verifies what has happened. As I say at the beginning of each episode, the competencies are all interlinked, so we will return to this example to explore how the competencies of communication and workload management could have been better utilised to produce a more successful outcome. These podcasts have an ultimate aim: to stimulate interest in the core competencies and inspire you to seek them out and apply them to further improve your effectiveness as a pilot. High Performance Pilot. Each week, one behaviour from one competency. We will break it down and provide tips and advice on how to make it a strength in your toolkit. Join me next week. If you wish to contribute or ask a question, please email me at david@sim2sky.com.